Good day to you, sir and madam. We are Group 1 and we are proudly presenting our smart library system built using the Amazon Web Services. My partners consist of Ding Kong Soon, Erwin Kwan Hee, which is myself, Tan Jun Wee, and Teo Wen Han. With that said, I think we can begin with our presentation. Okay, I will now begin our presentation with the background of the smart library system. A smart library, to put it in another way, is one that attempts to provide users with better and more advanced service. By definition, it is one that uses electronic and communication technologies to deliver specialized service. The term smart library appears in various contexts as a synonym for the concept of an intellectual library, digital library, or virtual library. The term smart also means flexible, adaptive, extendable, acknowledging, and human. The smart library is the integration of books and related data as well as digital and space resources based on the realization of comprehensive informationization of library. Use of large data intelligent analysis platform, the library management and services are intelligent and personalized, and the reader needs are oriented to improve their experience. Furthermore, a smart library can also be described as a hybrid of an electric library, a digital library, an intelligent library, a virtual library, and a network library. Smart libraries are completely and unconditionally reliant on technology. Without it, they would be unable to provide better services. In continuation, a three-dimensional model that defines a smart library in terms of the three key dimensions, technical, service, and user-oriented, is proposed. In terms of the technical dimension, intelligent libraries are self-renewing, adaptable, functional, integrated, efficient, robust, autonomous, and responsive, according to a researcher named Bailey. Smart library system acquires information for users based on their intent rather than requiring the library to be accurate, interactive, or user-friendly. The library's service dimension defines how it provides clients with seamless services that incorporate interactive technologies as well as quality, effectiveness, and efficiency that is geared towards users. Users may get computerized information like SDR, RSS feeds, current content, and access to ebooks on their Kindle service readers, PDAs, Mopacs, and other devices, as well as get and use library services on their PC and tablets. We'll now proceed to the history of the Smart Library System. The Integrated Library Management System, ILS, for library automation was the catalyst for change in the traditional library system. From ordering to the physical shelf in the library, ILS serves as a one-stop shop. It transformed library work systems from self-charging, discharging, and cycling enabled by barcode and RFID technology to the OPAC that most libraries are familiar with today. However, with the introduction of online libraries, their providers are unable to assess the expectations that come with them. Born digital collections and institutional significant collections have increased as a result of the rise of web-based content, outspacing efforts to sustain library print collections. Traditional IIS systems were inadequate for managing serial subscription, collaborative online resources cataloging, and e-reserve scan stations, among other things. Therefore, libraries and manufacturers are working to create a system that includes new technology to overcome this iOS weakness.
Hello everyone, my name is Teo Han. Now I will present about the future trend of the smart library system. Due to the time constraints, we only developed the smart library system with some basic library service such as borrowing and returning books, user account, and so on. The following are the features that can be added to our smart libraries in the future. In the coming future, we can expand the application of intelligence technology like user face recognition. This will give users great convenience because they can quickly access the library without going through a cumbersome user registration process. This can also prevent the thief of user identity from happening. Other than that, the smart library system also can add intelligent monitoring module. For example, the behavior recognition feature. This feature will help the admin to identify abnormal activity of the user. When the system detected the suspicious behavior, it will warn the administrator in order to minimize the loss of the library. This slide is about the problem segment of existing library system. Although there is already a library application exists, but the current existing system was slow and inefficient. It takes a lot of procedure when user want to borrow or return books. The information of the book may also lost. This usually is led by the loss of memory when the system crashes. The loss of the book may be hard to detect because the system handling approach was inadequate. This is also a time-consuming process when users want to find a certain book on the book rack. That's all for this part.
Our objective and proposed solution is to develop a smart library management system application based on the concepts of IoT and camera to propose a smart solution for libraries. We will use AWS as the platform for this project to build a library management system. The new system will manage and regulate all of the library's data, as well as address the concerns raised about and provide numerous benefits to staff and students. And this is the architecture diagram for our smart library solution built on the Amazon Cloud platform. So from our architecture diagram, you can see that IoT device like camera connect to the Amazon IoT Greengrass to create IoT solution that allow device to connect to the cloud or to other devices locally. The image from the boot rack will be collected by the IoT device and delivered to IoT core via IoT Greengrass. After passing via the IoT core, the data will be transferred to the Amazon service in accordance with the IoT rule set. The image gathered from the camera will be sent to the Amazon recognition via Amazon Lambda for data processing and analysis. Then the data will be sent and stored in the S3 bucket. When the book borrower return that is approached, the Amazon SNS service will trigger and an email is sent to the borrower to remind the book return date. Amazon Cognitor is used to create a login system to differentiate between students and librarians. Last, Cognitor connect to the API gateway, and API gateway connect to the AWS Lambda.
Generally, IoT cloud services are divided into three types, namely IoT application management, IoT device management, and IoT data management. IoT application management is a service that allows developers to create and manage IoT applications. The example is AWS IoT TwinMaker, Azure IoT Central. IoT device management is about updating devices and edge gateway to keep connected things up and running. The example is AWS IoT device management, Azure IoT Hub. IoT data management is a cloud services for connecting with edge device. Often they both provide storage and analysis of IoT device. An example is AWS IoT Analytics, Azure IoT Edge. In terms of service and products, AWS provides the largest section of network services, which is infrastructure as a service. The scope of AWS services tends to focus on solutions for large-scale projects, industry, connected homes, and business. Azure IoT provides a full range of IoT services, which is software as a service solution. It covers device management, telemetry ingestion, rule-based alerting, and visualization of end-to-end scenarios. Azure IoT is more focused on serving enterprise. For Google Cloud IoT, its scope for service is smaller than AWS and Azure. The main functions of Google Cloud IoT are maintenance and tracking of equipment, logistics, supply chain management, and smart cities. It also computing capabilities for artificial intelligence and machine learning.
Okay, now we proceed to the demo part of this presentation, which is the AWS console platform setup for our services. First, we go to the AWS console main page. We click sign into the console. I'm already signed into the console, so you can see here there are all the recently visited services. But today I will be doing the demo for Cognito and API Gateway. So we will start with Cognito first. So click on Cognito. Firstly, you can see that there's already an existing user pool created, which is the library user. Now for this demo, I will be mock creating another user pool. So I'm just gonna go ahead and create a user pool. So for the Cognito user pool sign-in options, we will use username and email. And for username requirements, we need to click on both of the options. Then we press next. And for the password policy, we will use the Cognito defaults. For any other thing in this, the multi-factor authentication, we will also use the recommended, which is require multi-factor authentication. And for user account recovery, we will enable the self-service account recovery. And we will choose the delivery method to email only. After reviewing everything, we can click next. For the sign up experience, we will use the AWS defaults, which is the enable self-registration, allow Cognito to automatically send message and verify to confirm, which is also the recommended settings. And for the attributes to verify, we will use the email message. And for the required attributes, phone number and email is not enough. So we will add name, birth date, and gender for the at least. Then after completing all the steps, we will click next. Going into step 4. For the email, for the configure message delivery, we will use send email with Cognito. And then we will create a new IAM role and give it a name. And we will press next to proceed to the next step. So for the user pool name, we will just give it a placeholder name. Okay. And then we will use the Cognito hosted UI for the hosted authentication pages, followed by using the Cognito domain. We need to give it an available name. Let's say we give it a 1, 2, 3. And for the initial app client, we will choose the public client and we will enter the client name followed by the giving it a callback URL. And for any other settings, we will just leave it at default. Press next. We now review all the options, and if everything is done, we can press create user pool, but I'm not gonna do that. So we will just go and review what have been created previously. So for this library user, you can see the Cognito has been set up. And for this, we can copy this URL to go to the Cognito main page. Okay, from then on, this will be our Cognito sign-in page. We can enter the username to sign in. If you enter the wrong password, you cannot sign in. However, if you need an account, you can create. And from what we set up just now, we need to enter all the attributes to create an account. That will be all for the Cognito demo. Now we will move to the API Gateway demo. Go back to the console and we will select API Gateway. To link our Cognito to the API, you need to use a REST API. But in this case, we will not be creating a new API, so we will just be reviewing the API that has been created. As you can see from the authorizers, we use the Cognito user pool, we set it into one of the authorizers, and therefore we can now we move back to the API, move to the API Gateway demo. Firstly, we need to create a new API. From then, we will select the third option, which is the REST API. We'll press build. Then we will give the API a name. And leave everything as default. Then we press create the API. The next, we need to give the API some resources. So we need to create a resource for the API. Can give it a name. Then the resources will be created. Furthermore, we will be creating a method for the API. This will be a get API. And for the API, we will link it to a Lambda function. However, the Lambda function has not been created yet. So we will be reviewing our previously created API. As you can see, there's the resource here and a method, one method here, which is linked to a Lambda function. And for the authorizers, we are linked to our Cognito user pool. That will be all for my part. Thank you.
Okay, now I'm going to create an IoT call for the SMS notification and also the SDK device. Firstly, we go to the IoT main page. Then we click on the Manage tab and click on the things. We need to create a things for this IoT. Select the create single things and give a name to this things, which is detector. Now we click next. We select an auto-generate certificate for this thing. We need to create a new policy. It will be directed to another tab. Then now we give the policy a name. We select the builder type for this policy document. Select all for the policy action, and also select all for this policy resource. Click create. Then the policy created successfully. We go back to the previous tab. We select the book policy that we just created. Let's select things. We need to download all the certificate and the key from these things. After done downloading, we click done. You can check the policy in the certificate that we just created. This is the certificate we just created. And then we can see the book policy inside this already attached in this certificate. Now I'm going to create the AWS IoT SDK, which acts as the device to interact with the AWS IoT. Okay, now we need to use the JavaScript programming to create this SDK. Then we need to store all the key file and the certificates file into one folder that we just downloaded. We use the Visual Studio to open the folder that store the key and the certificate, and then we need to create a JavaScript file. And then we need to go to this website to copy the device cards file for creating the IoT SDK. Make sure the Visual Studio Code already installed this two extension, because later we need to do some configuration. We paste the private key in this key path, and also paste the certificate file name as the third path. We copy the CA1 file name as the CA path. And now we need to go to the things we just created and go to the Internet tab. View setting to copy the endpoint for these things. Then we paste the endpoint in the host. Now we need to type in this command in the terminal to do the configuration for the AWS SDK. This is the process that running the configuration. After that, we can already run the code. Before running the SDK code, firstly we need to go to the MQTT test client. We need to subscribe to the device that we just created. Now we subscribe the book detector device. You can see that there is empty for this subscription yet. Then we click subscribe. This device will be subscribed. Then now we can go to the code and run the code. We can see that the message already published to the IoT. Then now we go to the MQTT test client to see the result. Then we can see that this information already published to the IoT. Now we need to create a AWS SNS to send a notification message to the user. Firstly, we click on the topic first. We need to create a topic. Then we select the standard type for this topic. And then we give the topic a name, which is then we create the topic. After we create successfully, then we need to create a subscription for this topic. Then we select email. We give the email we want to send to. After this, we create the subscription. Then we can see the pending confirmation of this. We can see that the subscription confirmation email already sent to me. And then I need to click the confirm subscription. After this, it will show subscription confirmed. And then we can check status again. Let's try to read it. The status show confirmed. Now I need to connect the AWS IoT with the AWS SNS. Firstly, we click on the Add tab and click on the loose. Now we click on loose for this. We give it a name and a description. And then we select the SQL version which is 2016. And then we give it SQL query. Then we select the add action. Select send a message as SMS push notification. Select configure action. Then we need to select the topic we just created. Select the book topic and then select your message format. Create a role for this use. And then we click add action. After that, we click create the rules. And the rules already created. Now the AWS SNS and also the AWS SDK already connected with the AWS IoT. Now we can run the code to test it first. Let us run the code. This code will publish the message to the AWS IoT, then we can check it on the MQTT test. You can see it. The message just send it into this test, and also we can look at my email. The message also just send to this email, and then this message is according to the use query statement that I just set it. It's not the same with the message just I published. That's all for this part. Thank you.
Okay, now let's talk about how to open Amazon Recognition at S3 and connect them. First, you can come to the Amazon Recognition page and then click Use Custom Label. So, click the hamburger. Okay, I change the region to show. If the first time to create the project, the system will ask you to create the S3 bucket. If you don't want to create here, also can go to the S3 page to create the bucket. So after create the bucket, you'll see the bucket in here. So click inside, and then you can upload your photo here. So first, I will create a folder first. Folder name is book, and then click the create folder. So here go the book folder. Click inside, and then click the upload, and click the add file, and then you can add your file inside, and then click upload. So after upload, the picture will inside the book file in the bucket just now. Let's back to the recognition. So now create a hamburger project, and then create a project. So let's create a project. After write the name and then create project. So after that, create the create dataset. Click the create dataset, and then start with a single data. Import image from S3 bucket, and then this you can copy here. Copy the S3 URI. Let the system come to your S3 file folder, and create dataset. Click the create dataset. Then we'll take a few minutes to finish it. Okay, after the few minutes, the project create. You can click here project, and then put classify project, and then add the label. So you'll see just now the picture in the S3 will come here. Okay, now let's go to I'm done with recognition. First, must go to the IAM first. Go to the row, here row, and then create a row. So click the AWS service, and then Lambda. Click the next here. So first, you must go to find the permission process, and first is the AWS Lambda. Execute. So, and then the second one is the recognition one. So it's Amazon Recognition Full Access. Amazon Recognition to access. So now got two policy enough. So click the next. Here we can type the name. So after that, just create a rule. So we can find the here. The row is correct, and then go to the function lambda, and then create function. So create this also from scratch, and here we'll use the Python 3.6, and the architecture is x86 underscore the 64, and then create a function. So after create a function, we'll write the code like this. Here, code, and create the text. Here, create the text. Create new event text. Then save. You need to here you need to write the bucket with the picture and the picture name. So create the text again, and then we'll see the response and the crash ID. Then we can click the deploy to save the code.
To configure Lambda with IoT Core, first go to the AWS Lambda sections, then create functions, select the author from scratch, and type the function name. The runtime, we choose the Node.js, and architecture, choose the x86. Then we create a change of develop, then use an existing role, and click the amplify login lambda that we created, then create functions. In the function that we have created, then the code here, we just type in this code to connect the AWS Lambda with IoT Core. First go to AWS IoT, then select rules. Then we create the detect rules that we created. Then we select actions. Click the send the message to Lambda functions. Then configure actions. Then we choose the function that we had created just now. Then add action. So now the Lambda function is already connected to the IoT Core. We go to AWS IoT and choose the Greengrass. Then we can set up one core device. Here we choose select an existing group, then choose the My Greengrass core group that we have created. Here we choose Windows OS and follow the following step to install the Greengrass core software. My step is shown here. Then after we configure, we can click View Core Device. It will show here if created successfully. Then we go to Configure Core Device Discovery. Here we choose the theme group and select the My Greengrass core group that we created. Now to configure and deploy the Greengrass component, we need to configure the client device and MQTT bridge. We create the edit configurations and copy the code to here. The code I will show here. This is the code for Greengrass client device authentication. And here is the code for Greengrass client device MQTT bridge. After done, you can review and deploy. And you shall see the components that we created here. We will configure the AWS Lambda Invoke API. First, we go to AWS Lambda and choose the function, then create functions. Choose the auto from scratch and type the function name. The runtime here, we choose the Python 3.8, and the rest we remain the default. Then click create function. In the function that we created, the code here, we just copy the code here and type this. Then we configure the API gateway, add the trigger here, and select the trigger, we select the API gateway, and we attach the get book that we have created. Deployment slash reset default and security set open, then create. Then the getbook was successfully connected to API. Here we will do the AWS connector connect to API gateway. First, we select the API gateway. Then we choose the Smart Library API that we created. Then we choose the authorizers and create new authorizers. We can give a name to the authorizer. Then we choose the type as connector. Then we link the authorizer to an existing connector user pool. You can give a token source to the authorizer. Then after that, we can create.